The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome back. Let's see. Jaden, you weren't here last time. Were you able to get my Inkscape installed? And did you? Nope. Okay. So while we give Kayla a chance to show up, perfect. Okay. And let me see. There's a couple of let's see, downloading and installing. You have a Mac, right? It's okay. So have you downloaded Xports as well? Okay, good. The most important thing is the first time you open Inkscape, if prompted to find Xports, point to Xports in your application's utilities directory. So, if that stumped some people earlier. Let's see. Also, it can take minutes. Inkscape, this is just for Macs. Inkscape is only actually technically works for Windows, but Xports is an application that Inkscape supports. So basically it lets you run Inkscape on a Mac, even though it's Windows. Also, Jaden, while you're loading, it can take, this says minutes. I've heard 10 minutes, sometimes even 15 minutes for it to load. So rather than hit cancel or anything, then just be patient. I'm not sure if this is just Mac. I think it is. Need your admin passcode. Okay. Well, I can send you the slides, Jaden, so that you have you can reference it. You know, it's nice to follow along, but you'll be just fine. You know, watching me do it. The installed Xports folder. I'm running a Windows machine. I'm not sure the folder that it installs. You mean like download it from the internet? That's as far as I can get it. Download the program here. I can click download, and I can get the DMG file. Windows won't let me take it past that, so I'm not sure if that's good enough for you. I don't think I can, since I don't have a Mac. Yeah, I'm sorry about that. Yeah, well, I guess we'll go ahead and get started. Jaden, really don't worry about it. I think really what I want to cover on Inkscape is something that is fairly easy to do when once you know how to do it. So just keeping up, following along will be, good. You just need to know the material. So, yeah, the steps to take, and I'll send this out to you guys after class as well, because I know it helps. I can say it, and you could find it on YouTube if you needed to, but it helps just to refer to the material. Sometimes it's faster that way. So, what the goal with Inkscape is to take some file that we find on the internet. In this case, I went to Google and I searched duck clip art, and you get a bunch of ducks. Nope, I did image search. Bunch of ducks here. I could search. Google has search tools. Let's see, type. Maybe that's not it. Inkscape should be pretty quick. SVG. So you can search SVG files, but your results usually get pretty limited. I haven't explained what SVG files are, though. Okay, so let me back up a sec. Okay, vector graphics. What are vector graphics? And why do we care? So, and also, why do we care about Inkscape? Inkscape is a software program that lets you draw and edit vector graphics. I'll explain what that means in a sec. Vector graphics are the representation of images based on mathematical expressions. They're based on vectors known as paths, which lead to locations known as points or nodes. That's a lot of terminology that we don't really care about, because this is the important part. Other images, JPEGs, GIFs, GIFs, bitmaps, BMPs, are made up of a grid of pixels, collectively referred to as raster files. Whereas vector graphics are mathematically defined paths with, including the curves and the angles and everything. So what does this mean? When you blow something up, the mathematical enlargement can calculate exactly what that letter looks like and what those pixels look like. Now, if you blew up the bitmap image, the JPEG or your raster file, they get that pixelated look. I'll show you here. This is the duck graphic that I ended up finding, and so this is what it looks like. It's a JPEG, which is one of our raster formats. Now, what happens if I zoom in on it? So I zoom in, and get bigger and bigger. See that? The image quality really breaks down. You can really see each pixel, just becomes a bigger pixel on the screen. So what we want to do is to be able to blow it up as big as we want to use it. So let's go. Okay. So if we can take a bitmap and convert it into a vector file, then we can blow it up to any size. We can also do things like import it into programs that we know, like Tinkercad. So Inkscape's the tool that helps us convert raster files, the collection of pixels, into a mathematical definition of what the shape is. You can also import these kinds of files to OpenSCAD as well. If you've done Scratch before, I haven't, but if you have, they use vector graphics that makes the mathematical computations a lot easier. It actually speeds up, using vector graphics speeds up the calculation of where everything needs to go, because rather than loading a huge file that tells each pixel by pixel where they go, it has a very fast mathematical definition, and it doesn't have to search the whole hard drive. The hard drive sends over a very small amount of data, and the graphics processor, which is very powerful, can calculate that in a nanosecond. So again, it might be difficult to see once you get there, but let's see. Let's close this. You can tell vector is nice and clean, the bitmap not so clean. So another use for them is in logos. Pretty much every single logo will be defined as a vector file, and then scaled to whatever size you want. So you could scale it down to your stamp or piece of paper, or scale it up to a billboard, and it's going to look, the S is going to look exactly the same, or every letter, every shape is going to be exactly the same without the pixelation that you get. So we don't care about the downloading and installation. We'll skip over straight to how do we do this. So why do we care at all? We've covered that. Now how do we do it? So let's say you need a duck graphic for a Scratch game, or maybe you want to make a vector graphic. So you need a graphic so that maybe you want to print out on a 3D printer a duck, for instance. I don't know why you'd ever want to print out something on a 3D printer, but it could come in handy. So that's sarcasm, by the way. I don't often use it, but sometimes it slips out. Okay. So you can search, once you go into Google, this is what I was looking for earlier. If you go into Google, you go into advanced search, you can search for SVG files, or .svg. That's the file extension for vector objects, kind of like a .jpeg or .bmp for bitmap, .png. These are file extensions, so that's how you know it's in a vector format if it's got .svg at the end. You can go to Google and click that certain file type, but like we saw, you don't get the variety of ducks if you're, for example, that's just the example of the day is a duck, but you might not get what you want, or as the variety that you want. So instead, this is arguably a nicer looking duck. Maybe it fits whoever picked this, who made these slides. And maybe it fit suited their needs better than all of these rubber duck looking ducks. This is a more regal looking duck. So what we're going to do, the technique is called tracing the raster image, which, like I said, is the JPEG or that sort of thing. Oh, I can change that. I can't believe it. Every single time I have to edit my name. From Josh Pearson. There must be a setting somewhere I haven't found yet. Okay. Yeah, tracing the raster image. So how do we do this? So we go to Inkscape. Let's see. Have it open over here. File. Import. And I have to save this file. Where did I save it? In my documents. Okay, right here, duck JPEG graphic. Okay, go to defaults. All right, so here is my duck. Now, what next? So, oh yeah, and if you'd like to follow along. Does it have to be SVG? No. This is what we're importing right here into Inkscape is not SVG. It's all of whatever else. Inkscape can certainly open an SVG file, a vector file, but if you've already got the vector file, then all you're doing is image manipulation. You're changing the shape, or if you've got a vector. So how do you get your picture in there? So I already downloaded this duck, but if you have a picture saved on your computer, let's see if I can I'll open up a folder. Actually, let's see. Okay. Here, so I went to, you can go to downloads, if you've got some, if you've downloaded the picture, basically you just have to know where your picture is. I happen to know that mine is in my documents, so I just need to know exactly where it is. I saved it as duck JPEG graphic, so I remembered that this is the JPEG file, it's duck, and it's graphic. Doesn't matter what you name it, doesn't matter what it is, but if you go to the internet, if you want to get it from Google, then we'll go back here, open a new tab, and type in Google. Oops, lots of Google. Okay, go to images and type in whatever you want. You could get a car. I will suggest that you use an animation to start off with, because it's just easier to, I think you'll have better luck starting off learning how to do this with a, adding clip art or something, and it also will help if it's outlined. Like, for example, this car here, it's outlined in black, so that helps. It certainly doesn't have to, but I can search for you could even do an Iron Man, or pick your favorite superhero, or anything really. It doesn't matter. The point is, whatever you want. And don't even worry about making sure it's outlined in black or whatever, like I said. Just experiment with it, because it's actually, there is an experimentation step that we're just about to get to. So, and some pictures just work better than others in Inkscape. But I'm going to go back to Inkscape. And so now that I've got my duck, you'll notice there's two tools here on the side. One is this arrow here. This is the tool that lets me, as I hover over it, it says select and transform objects. So when I click, I can keep clicking on the same duck, and I can drag to make it bigger that way. I can drag to make it bigger that way. And maybe I just want to try and see what it looks like when it's really big. So I try this, and I can tell that this quality is pretty poor. I'm not sure if you can see that, but I can tell for sure that some pixels are getting stretched. I'm going to Control-Z undo all those changes I just made. Now another thing you'll notice is if you click again, the arrows change. So I click, and the arrows change, to stretch. Now I click again, and the arrows change to rotate. So what this is doing is rotating the image around. Unless you are rotating your image exactly 90 degrees or 180 or 270, so that you have right now this picture is a square. Unless you rotate it in a perfect, along one of the edges of the square, I could if you hold down Shift, I think, oh, let's see, click again. If I hold down Shift, it'll restrict where I move it. That didn't work. If I hold down Control, maybe? Yeah, if I hold down Control, it restricts to certain increments. So if I rotate it by exactly 90 degrees, then this duck is sideways, then that doesn't actually lose compression because it can take all those pixels and just move them around. But I just undid that. But if I move this here, some of those pixels aren't actually defined once you rotate it. So it has to actually reduce the image quality a little bit to do that rotation even. So that's not a good thing either. We don't like losing image quality. That means when we want to make it big, we can't do much with it. Now, the only other tool on the side here that we need to be concerned about is this tool down here. It's called Edit Paths by Node. So actually, we're not even there yet. So click on your duck, or click on your image, right-click, and go down to Trace Bitmap. Click on that, and you'll get a screen here. And you have a couple of options here. So, what are we doing? This is the magical step where Inkscape takes our image and converts it from a collection of pixels to a mathematically defined path with nodes like we covered before. So the main options are there's a couple of different options. Let's start off with the first one. Single scan creates a path. So it's a cutoff on brightness. Well, I know that colors are very obviously defining paths in here, so I'm just going to go ahead and pick the one that has color in the name, color quantization. I don't really know what this means, but I'm going to go with it. And I want to see what this looks like, so I can either click Update or Live Preview. I'll click Update, and that's what it's going to do. That doesn't look like it's very good quality to me. It's definitely lost some shapes here, so let me go with a different one. Let's try edge detection. I'll click Update. Oh, that looks better. See how it's creating, well, that's obviously better than color. I'll go back. Actually, I'll click Live Preview so it should just update itself when I move it around. So that one's not so great. Edge detection, that's getting the color edges pretty well. Brightness cutoff, okay, so that one is kind of picking the dark images versus the light images, and it's only picking two. This is a single scan, so what the single scan means is it's going to select something and eliminate other things, and it's got one choice: do I include it or do I not include it? Now, what if we go down into multiple scans, create a group of paths? Well, besides the fact that we don't really know what this means yet, let's just see what it looks like. I click brightness steps, and it doesn't really look like it changed very much. What about colors? Okay, so colors kept the colors in there. It's a little fuzzy maybe, but let's try grays. Also, maybe a little fuzzy, but still pretty good. Let's go back to colors, grays. So what you're looking for here is how sharp is the image? How good of a quality is this image? And I'm struggling to tell the difference between the colors and the grays. But when I go back to brightness cutoff, that's clearly worse. Edge detection, it's okay. Color quantization is awful. So what you'll find is that for different images, different techniques will work, and that's why they give you all these options. We're not going to go into what these values mean here, but if you're particularly adventurous, you can just mess around with them. Color quantization, colors sounds a lot more obvious. That's the number of reduced colors. Brightness steps has 8 scans, so that's how many scans it's going to do. So it's going to take 8 different steps, whatever that means. So let's just pick one that sounded pretty good. The brightness. Let's see what they did in the other one. I mean, in the slides. Just stay consistent. Single scan, multiple scans. So we'll cover what this means in a sec. Basically, the single scan creates one path. Multiple scans creates a group of paths that are layered together. We'll get into more of what that means, but it looks like so it looks like they went with either the grays or the colors. That's what I would have picked too. Go back to Inkscape. Okay, so let's do colors. I click OK. All right, so now it's running. Now don't click OK a bunch of times. It looks like it leaves it up and it makes it, you think that it hasn't done anything, but it really has. So click close out of that. Now we're going to go to this little tool here that I mentioned earlier, Edit Paths by Node. Click on that, and then just hover over your duck and click. You'll see a bunch of little gray lines. So this is the path. All these dots are the path. Now we go back to, all we used this Edit Paths by Node, this tool, was to click once on the duck. Now we click back to the selector tool and drag the duck off. We go back again and select a different path. Remember we did the multiple paths option. So we're going to pull off different paths of the duck. Let's go again here. One for each color, and we'll see how they're different, slightly different. You just have to keep switching back and forth between the tool. If you want to be a little faster about it, it looks like you can hit F1 and F2 to go back and forth. But basically what we want is to find out, or to choose, which path do we want? Which one looks the best? Okay, so there's all of the paths that this tool made. Now, this path, this one right here, the path that I never actually really moved, this one. This one here. This one, I'm going to argue, doesn't add much. We can go ahead and delete it. This path also looks okay. You have to select the paths with the path selector tool. When I click here, this tool thinks everything is one image until I select a little group. And notice you can move this path around. Like I can make this path, I can change it up. I can add, this is me actually defining the path. But you can change the shape of the lines here. This is how the path is defined by a point, and then at what there's a definition that defines this point, this line, and how it relates to its neighbors' points and lines. That's all it is. But I didn't really care for this path in the first place either, especially now that I've distorted it. But you can't really see as many features as in the other one. So I'm going to go ahead and click on it and delete it. Oh, I have to click on it here and then delete it. Okay, back to this tool. Now, it's really about picking the one that has the most details that you like. So I think this one, this black one here, captures the most details. You can see in the wing, it's really got the wing sorted out nicely. So I'm going to go ahead and delete all of them except for this black one. forgetting. You have to. Oh, and apparently there's the background too, which you can delete. Huh. Okay, so there's our original file underneath. So actually what this did was it didn't do anything to our old file. It just put all of the rest of the images right on top. I mean, all of these raster images right on top. So when I move this around, let me put them pretty close together. Oops, too close. Okay, put them close together, and now I'm going to zoom in. If I can figure out, there we go. So look at the difference. See if you can tell the difference. Do you see that? I'm zooming in more and more and more. And look how this file right here, this line, is really pixely and jagged. But this one, perfectly smooth. I can keep zooming in on this. And no matter how much I zoom in, it's a mathematically defined line. It's not going to get any. Its definition is great. It's as good as we want. So we can go ahead and click on this one, delete it, and let's see. We've got maybe one more step before we import it. Let's see. And maybe let me make sure I didn't miss anything in the slides. Oh yeah, so after tracing, it's suggested that you try path simplify. It looks like that's Control L on the output path to reduce the number of nodes. So let's try that. Now, reducing the number of nodes is going to reduce the quality, but Control L. I didn't see much change there. I didn't see anything happen when I clicked. But look how many nodes there are. There's still a lot, but not nearly as many. And look down here. It says path 93 nodes in the group. If I undo that, and I click on this path again, 180 nodes in the group. So I'll do Control L again, 93 nodes. For very minimal reduction in quality. It's not you can't see it, so does it really matter? Probably not. It could in some instances. You might notice the quality go down, but in this case, the quality still looks great. So we just simplified our object and made it much faster to import and to move around and to manipulate with a minuscule reduction in quality. So that's important. That really can help speed up your, it simplifies your file, makes it a smaller file, and also speeds up moving it around. So what's next? We want to go into document properties and resize page to content. So I'll show you exactly where that is. Go to File, Document Properties. You could also hit Shift-Control-D and resize page to content right here. Open that up. Resize. Oh yeah, you have to click on your Docker graphic first. Then resize page to drawing or selection. All right, now we can close that back. And what that did is, if we drag this off, you can see that there's actually, now this file is right there. I'll hit Control-Z and go back. So this is the size of the file. We don't want to include all of that extra white space, that's kind of junk, in there, in our file. We don't want all that. We just want the minimum specs. So one last thing you'll notice is if you click here, there's a couple of, let me zoom in. Oops, did I do anything? Control-C. Oh, no. Okay. Let me zoom in before I highlight that. Okay. Zoom in and you'll notice there's a couple of extraneous things here. Let's see if I click back here, you'll notice this dot. What's this dot doing here? Doesn't really, it's not part of the duck. So I'm going to delete it. Here's another dot. I'm going to delete that. Here's another dot. And delete that. You'll know if you're deleting something important because you'll see the shape change. If I delete this, oh, that changed shapes. So Control Z, undo that. I want to keep the shape of the duck. But some files, sometimes you'll find that it pulled off a piece. If I undo those things, you can see there's little tiny dots here that it, for whatever reason, because they were part of the other picture, it decided to keep. So you can manually edit out those dots. If there's a lot of them, we'll see another option later that can, is an alternative to individually deleting dot by dot by dot, which can take a while. That actually shrunk my document a little bit. So I'm going to go back to Document Properties, Resize Page to Content, Resize Page to Drawing or Selection. Okay, did that again. Go back. And now this is exactly what I want. So what's next? Well, let's go back to the slides just to make sure I haven't missed anything else. I think okay, we cropped the document. Now we won't get any extra white border in our export. Save as SVG. So this is pretty easy. Definitely we've gotten through the hardest part of figuring out which image we wanted to keep and which save as Inkscape SVG. That's not only Inkscape's their files, but Inkscape can certainly read them. And we're going to save this as duck SVG graphic. Whatever you want. Doesn't even have to say SVG. Actually, the file name itself, if you change the setting in your Windows or Mac to show file extensions, you'll see it's actually duck SVG graphic.svg once I save it. Okay, so actually I'll show you that. Go to my documents where it's saved. Maybe I didn't save it in my documents. Did anyone notice where I saved that? Let's go back to Inkscape. That's important, noticing where you save things. Save as David Cato. Okay, now I want to save this in my documents right here. Duck SVG graphic, save. Okay, now go back to my documents. Here it is, duck SVG graphic. Over here it says in the type, I imported the JPEG image and I exported an SVG file. All right, so now that we've got our SVG file, let's switch over to Tinkercad. Okay. So, in Tinkercad, I'll give you guys a sec to catch up in case you need to. I'll do this pretty slowly, but it's pretty simple. You've got all of these options on the side here, favorites, import, shapes, everything. So we want import. Surprise, surprise. We want to import a file so we can browse for that file. And here it is, duck SVG. Open. And we wait for a little bit. Oh, yes, scale 100%, height 10 millimeters. That sounds good. Remember, this is a flat file. So, and it knows that because it's a .svg, and that's a 2D file. So we can give it a height. We might as well give it 10 millimeters since that's the height that we can print things, according to Mr. Dubik. So we click import, and there it is. That looks pretty big right now. We can certainly change the size, but that's all Inkscape. You guys know how Inkscape works, so I don't need to show you. But I guess I could remind you how to change the size. Find the little, trying to find the corner that's easily accessible. Okay, so if I hold down Shift maybe, yep, that locks my dimension so I can make it, let's see, I want to make it no bigger than 80 by 80. So looks like if I make it right there, okay, just under 80. Oops. Oh, how do I move this around? There we go. Okay, so zoom back in, rotate back around. So there's our duck. Now, what can we do with this? Well, you can do anything that you could have done already in Tinkercad. It's just another object. Now, it's important to remember that this is a single object, even if it's in multiple pieces. Even if there was a piece over here and maybe I hadn't deleted those pieces. Imagine a big, block of piece over here. Well, that's still one object, so I can't select them individually because they're all attached. So the options are to either delete it before you import it, or remember, Tinkercad has holes. So if you wanted to just cover up that hole, that piece with a shape and turn that shape into a hole, and then merge that whole shape with your duck or whatever file that has that extra piece, then that will also eliminate that piece. You can manipulate this just like you can any other geometric objects in Tinkercad. So now this gives us a really big advantage, which is being able to import anything we can create, we can import in here. And in particular, since we can only print 10 millimeters tall, we can do cool things like if you go into geometric, get a cylinder and bring the cylinder in here, and we could change the size. Let's see, what do I need? I probably need a ruler first. Okay, so if I change this to 80, and change this to 80, and change this to height to 3, note that if you're actually doing this, don't use a height bigger than, less than 3. You can for pieces, but for a big disk, it should be at least 3 pieces tall, or 3 tall. Now, what is up with this? Oh, okay, this use units is not, these units aren't millimeters. So if 2.67 is 10 millimeters, then we actually need to make this smaller. But you get the idea. So let me just make this 1. I don't know what unit this is, but now our duck fits on top of here. This is just a stylistic change. Oops. Make this duck fit, and now I have something like a medallion or something like that. This is just to give you some ideas. I could add my initials or whatever, and use a hole for the eye. Yes, that's a good idea, Jaden. So one thing we never captured was that eye, the eye of the duck. I'm not even sure if it had one to begin with. Let's see. But it doesn't matter. If we want an eye, then we just put a hole for where the eye is, and then we have an eye, which is perfectly reasonable. Yeah, it does look like it has an eye. I guess it missed out on that. Actually, it took the whole green section as black. So the real art to this is in playing around with this page right here, the trace properties. You'll find that some things, for every image it's different. Maybe you can figure out what images you can guess which node will do better, but in general, multiple scans will usually do better than the single scans. So definitely try those first. The problem with multiple scans is you have to figure out how to, or which one to keep, which file, which layer to keep. Gabe says you lost connection part after you finished bitmap. How do you put this on Tinkercad? Okay, so Tinkercad, that's an easy question. Okay. Go back to Tinkercad. Okay, you never saved it. Let's see. Well, importing it to Tinkercad is easy. Jaden, I'll get to your question in just a second. So go to Tinkercad. On this bar here, you'll see favorites, helpers, shapes, all that. Click import. It's already on file. Click browse and find that saved file. So it's pretty easy. You click import. So if you've never saved the image, go back to Inkscape where your image is. The reason why this is let's see, I did zoom in here, but the reason why this image, to save it, first go to document properties, and you'll want to resize page to drawing or selection. You might have to click this resize page to content first. Right here, this is document properties, resize page to content, resize page to drawing or selection. All right, and then you click File, Save As, pay attention where you save it. I made this mistake already. And I want to save it in my documents. I renamed it Duck SVG graphic, so I remembered. That was easy for me to figure out. But as you can see, it also tells you it's an SVG file and that sort of thing. So, so you hit Save. I'm going to hit Cancel because I already saved it. And then you can import, from there you can import it to Tinkercad. All right. Any questions? I know that was, I didn't really take any breaks on the way through. Oh, sorry. Thanks, Jaden. What are we doing after Inkscape? So we still have more OpenSCAD to cover. That's what we're doing today, and probably next meeting as well. We'll have a bit more OpenSCAD to work on. Yeah. See, Kayla, I'm not sure when you came, but I don't know, did you catch things from the beginning? I didn't see when you arrived. Or is there anything that you found particularly confusing that I can answer quickly? Or anyone else? Any questions really from anyone? Oh, so you didn't miss anything hardly at all. Good. Gabe, if you want to send your Tinkercad, you're happy, you feel welcome to. I'm happy to pull it up. That same goes for anyone else. If no one has any questions on how to do this, I will cover, there are a couple more things that you might find useful in Inkscape. Say you want to create rectangles and squares. Well, there's a handy-dandy tool. We only covered the select and edit paths buttons, but there's also create rectangles and squares. You can create rectangles and squares. It's pretty easy. You can create circles, ellipses, arcs, that. If I hold down Shift, that didn't work. If I hold down Control Shift, oh, okay, it's kind of limiting my shapes. You know, it'll keep it. I keep it here. Actually, it's showing. Yeah, they can make a perfect circle if I hold down the right key. So just play around with it. Do stars. Do spirals. Gabe says, "Wait. What do you want to wait on, Gabe?" You could totally make buttons for your jacket. You could put your initials on your buttons for your jacket. You can put, I keep using this example because it's really simple, but you can make whatever you want. And you can even draw with a pencil. That's my, oh, okay, I don't know, just click and draw points. You can just draw whatever you want. You can continue off different points to connect the dots. That kind of looks like a sock eating another sock or something. I'm not sure. But you get the point. There's other tools. That's not all that Inkscape is good for. It's a really powerful tool, but one of the really nifty features is just being able to take any file and turn it into any raster file and turn it into a graphic. All right, so that is Inkscape. Okay. Why can't I hide this? He wants to show us his Tinkercad or his imported design. Yeah, Jaden says OpenSCAD is cool. It's very powerful. It's really cool. So, that's pretty cool, Jade. Gabe? Let's see. Copy and paste. We can see the sun wheel. And there it is. Yeah. And you could make that a button or whatever you want. Exactly. So, that adds, I think that makes, you don't have to be a graphic designer to do this and still make really, really cool shapes and things. So I'm a big fan. Let's see. That's really, there might be a little more in the slides. 3D printing. Yeah, we're 3D printing in Inkscape, so we don't have to cover that. All right, so OpenSCAD. I sent, you have the whole deck of slides here. So if you want to go ahead, you certainly can, but we're still going to cover all the material. So, try not to zoom too far ahead, or you might, feel bored in class. But you can certainly do whatever you want. So we introduced, last time we had a quick dumbbell challenge where we gave you this. Here's the, whoops, that's the solution. Here it is. Okay, here's the code for the dumbbell. Missing one, and there were a couple of ways of going about solving this. This is what you have before you fix it. One solution is to combine the shapes. Let's see. translating sphere, cylinder. Okay, this is the solution is figuring out what shape you need, how big, where it should be centered, what axis it should be in, what direction the shape should be moved to. This one's pretty simple because you just need another one of these on over here on the other side of the x-axis. There's two ways to do that. That are well, there's a lot of ways to do it. There's two ways that are relatively simple. You copy this line here, translate -10 along the x-axis, a sphere of radius 5. That one was already there, so if we put another sphere in there, instead of -10 on the x-axis, put it at +10 on the x-axis, that will give us our solution. Another solution would be to take the same sphere here and realize that we can just mirror it across the x-axis. So when we apply this mirror to the x-axis, the exact same shape, the exact same placement will happen. We've just taken a duplicate of that object and mirrored it to the other side. So both are perfectly valid solutions. So we started getting into, I think I briefly mentioned some colors. This doesn't necessarily affect your printing. Sure, Jaden, I can go back. So as far as colors go, it won't affect what color, what is actually printed, but it can help you figure out what shape is what. We went through a troubleshooting tool last time, a couple of troubleshooting tools, which if you missed it, you can either watch the YouTube video from last time, which is online, and I'm going to post this YouTube video too. I'll try to get them posted on the same night, but sometimes it takes a while for the video to process. So I'll definitely have them up now that I've figured out how to do it. I'll definitely have them up on by the next day. Gabe asks, can you print a turbine, a water turbine? If it fits in the dimensions, then sure, you definitely can. If it doesn't, then make a bunch of different flatter, cross sections of it, and glue it together yourself or something like that. Oh yeah, that's right. So with this, you might think that 10 millimeters, it's not, and by 80 millimeters isn't huge, and that's because even though we can have the ability to 3D print, it's still pretty young technology, and so it takes a while to be able to scale this up to a larger size. So it's still pretty expensive to be able to print things out that are somewhat large. So one option is, since we only have 2 minutes, I think we'll not cover any more OpenSCAD for the day, but I'll switch back to Tinkercad. So there is an option in Tinkercad. I haven't tried it, but you can go to Design, download or order a 3D print. And there's 3 sites here that they forward your design over to this site, and you can actually order it. So if you save up some money, then you can, here's at least 4 sites that will print your design for you. If you don't want to use one of these sites and you have another site, or have a friend that happens to own a 3D printer, all you need is the file, which you can download from here. You click Design. You can either upload it to Thingiverse, download for Minecraft, download for 3D printing. That's probably the one you would want. Download to 3D printing, and remember that we use, typically you would use .stls. Yeah, I don't really know what download for Minecraft means, unless maybe it breaks it up into blocks that Minecraft would use. I really don't know. You can even download a 2D cross or 2D section, a cross section. You have to define which layer you want, but you can also download a SVG file, which we just learned about. So you can take things from Tinkercad and take a 2D cross section that is defined as a vector and go back to either Inkscape or, as it says here, you can make a laser cutting. So a laser cutter might you cut through a block of a sheet metal or a block of wood or something like that. So there's a lot of options, and you're really not limited since you can export the files themselves and import them into wherever else. But those are some options available to you. I think you'll probably, while you can certainly do whatever you want, I think as far as printing with Mr. Dubik, something like this duck would definitely hold up because it's all connected. If you've got something that's not, some pieces that aren't connected, you might prefer to stick them all on something like a disk, especially if I had, a couple of letters. I wanted my letters up here, then, those aren't connected to the duck, so they're not going to stick together. If I want them to stick together, I need to make a piece here to stick them together, that sort of thing. So, yeah, duck blocks. But there's some ideas, and I just noticed we're 2 minutes over, so with that, I hope you all have a good night, and I look forward to seeing you on Monday. And feel free to email me questions anytime. I do go to work, but I will always check my email after work. If you have any questions with design specs, or how do I do this, or is there, if you're struggling with a picture. I actually live in Madison, Wisconsin. I just moved out here for a job, so I'm on a. For me, it's 7:02 right now, about to be 7:03. Yeah, so it's been fun. And I moved to Madison, Wisconsin for a job. Yeah, I'm originally from North Carolina. That's where I met Mr. Dubik and found this opportunity. So, all right, have a good night.